Does the new input system in Unity feel like a headache? I've been using Unity for 9 years and let me tell you I feel exactly the same way. But in reality, it's much easier than it seems. You just need to understand it. And for that, in this video, I'm going to give you a series of tips to help make it simpler. Stick around, let's get started. First, we need to understand how it works. Unlike the old system, we don't think in terms of keys, but in actions that group buttons and inputs together, much closer to the old input get button. For example, we have the attack action, and if we expand it, we'll find all the assigned inputs: gamepad button west, mouse left button, primary touchpad, joystick trigger, or the enter key on the keyboard. Before we begin, let's assign a player input component to the player, or to a game object called input manager or whatever name you prefer. Understanding this concept, the first thing we need to do is map buttons to actions. To do this, the new system uses a file called input actions. You can create a new one by right-clicking, create input actions. Here's a quick tip. You don't actually need to create a new one. In newer versions of Unity, when you create a new project, you already get an input actions file with a really solid default mapping. Here's the important part. Don't use that file because it's pre-configured singleton and we won't be able to customize it properly later on, so select it, duplicate it with Ctrl+D and rename it. Once duplicated, select it, go to the inspector and click the button to edit the configuration of this file. As you can see, it already comes with several mapped inputs that we can reuse instead of starting from scratch. The only thing we need to understand about how this setup works is the following. If we want to add a standard press input, like a key or a controller button, we select Action Type Button. If we want a continuous input over time, like movement with arrow keys or a joystick, then we select Action Type Value. Now comes the tricky part, especially if you are coming from the old system, but it follows a method that in practice works exactly the same. I'm going to break it down for you so you only need to understand it and apply it. First, create a new script where you'll handle the functions of the new system, and then assign it to the same object that has the player input component. Let's start with button presses. We'll do this using callback functions, and I won't lie, you'll need to remember this structure every time you use it. Public void function name input action dot callback context. Now this is easier than it looks. To replace the old input GetButtonDown, that is, pressing a key or button ons, we use a conditional with the context variable. If context.performed, and inside wherever you want to happen when the key is pressed. On the other hand, to replace input GetButtonUp, meaning when the key is released, we use the next conditional using the variable context. If context.cancelled. If you want to test it, I'm leaving these two statements on screen. For this to work, go to the inspector of the object where you assigned player input and drag in the player actions we duplicated earlier. Then go to default map, select player and change behavior to invoke Unity events. Expand the event section and you will see the mapping categories, in our case player. You will see all the actions defined in the input actions. Just click the plus icon, assign the object with the script and select the function we created. Now you may be wondering how to replicate the old get button, that is, executing something every frame while a key is held, like for a charged jump. We can simulate this very easily with a bool variable that stores true when the key is pressed and false when it's released, like I'm showing on the screen. Once we have that, in update, we simply add a conditional. If that bool is true, execute wherever you want while the key is being held down. But earlier I mentioned that there was also the value action type. These are used for keyboard's arrows, mouse movement, and so on. They are inputs that constantly register a change in value. You could also use callbacks for this, but it's not the most recommended way because we need to keep track of these values inside update. So I'm going to show you a little trick to correctly and easily recreate the allInput.getAxis. First, we're going to declare a variable of type player input, which will give you access to the input mappings we've created. Second, we declare an input actions for movement keys and another input actions for mouse input. Now, in start, we need to make sure those variables are assigned. For player input, we'll use getComponentPlayerInput. For this to work, remember that the script must be on the same game object as the player input component. If you are not comfortable with that, you can make the variable public and assign it manually. Once we have access to player input, we'll use the structure playerInput.actions action name. For example, the movement action is move, and this mouse action is look. Remember, you can find those names inside the player action setup. Once that's done, it becomes really easy. We just have to use the structure readValueVector2. For example, to assign movement to an input, try this line of code. Vector2 raw input equals move action dot readValue vector2 and print it in a debug log. If you want to check mouse movement, use mouse action instead of move action. Now we are missing one last concept. In the old system, input.getAxis had a built-in smoothing. We can recreate that pretty easily as well. First, create a vector2 variable called, for example, smoothInput, and a second variable for the smoothing speed. I've called it smoothSpeed, with a default value of 3.0f. Now go to Update and we'll use a built-in lerp function from vector2, which allows us to create a smooth transition, so we write smoothInput equals vector2.lerp, open parentheses, and inside the first parameter should always be the current value, in this case smoothInput. The second parameter is the target value, which is raw input. Finally, the speed. We use the smoothSpeed variable we created earlier and multiply it by delta time. Now put it into a debug log and test it. Expecting something more complicated? I avoided the new system for a long time too, but with this simple tutorial I hope you now understand perfectly how it works without overcomplicating things or diving into confusing documentation. The good part is that the new system's input mapping is actually really powerful and useful, so I hope this video helped you out. If you liked it, drop it a like and subscribe. See you in the next tutorial.